Yes, students, here we are having two questions, first and then second. So first we'll go with this. A force of 6.25 Newton acts on a charge of 25 into 10 raised to the power minus 4 coulomb. The intensity of electric field at that point, that we have to calculate. Now we go through the electric field. Electric field is the force experienced by a unit positive charge. So if we see here, E is equal to F upon Q. Now here, the force is given to us and the charge is also given to us. So if we calculate it, we will get the answer. This is 6.25 Newton and 25 into 10 raised to the power minus 4 coulomb. So electric field 6.25 into 10 raised to the power 4 divided by 25. So it is 0.25 into 10 raised to the power 4. If we solve it finally, so we will have electric field, that is 2500 Newton per coulomb. 0.25 into 10 raised to the power 4. So this will be the final answer, and the answer, correct answer will be this B, 2500 Newton per coulomb. The unit of the electric field is Newton per coulomb. The unit of force is Newton and the unit of charge is coulomb. Similarly, another unit which we know, that is volt per meter. The unit of SI unit of electric field is Newton per coulomb as well as volt per meter. That must be kept in mind. Okay. So it is a simple one. Now here we have another question which is somewhat based on the equation of motion also. If we go through the question, we will come to understand it. A particle of mass 10 raised to the power minus 3 kg. Means mass is given to us 10 raised to the power minus 3 kg. And charge 5 microcoulomb is thrown. Q is also given to you 5 microcoulomb, that we can have 5 into 10 raised to the power minus 6 coulomb. At a speed of 40 meter per second against a uniform electric field, means initial velocity is also given to us, that is 40 meter per second. Against a uniform electric field of strength, E is also given to us, 2 into 10 raised to the power 5 Newton per coulomb. The distance traveled by the particle before coming to rest. Now here, when it is thrown in the electric field against an uniform electric field, means it is experiencing some force, because we know that electric field which is given by force per unit charge, F. Now we can determine F with the help of this electric field multiplied with this Q. So here the charge which is given to us 5 into 10 raised to the power minus 6 and electric field is given to us, that is 2 into 10 raised to the power 5 Newton per coulomb. So here we are having 10 and 10 raised to the power minus 1. So we can have the F is equal to 5 into 10, 2, that is 10, and it is 10 raised to the power minus 1, means 1 Newton. The force which is acting, that is of 1 Newton. Now this 1 Newton force is acting on this mass, on this charge which is having a mass this much. Now if we go through the Newton's second law, so we can determine the acceleration, that is F is equal to mass into acceleration. Now mass is 10 raised to the power minus 3 and this 1 10 raised to the power minus 3 into 8. So here we are having acceleration, that is 1 upon 10 raised to the power minus 3. Force is 1 Newton. So it is how much? 1 Newton is the force and this 10 raised to the power minus 3. So 1000 meter per second square. Okay, so here we know that V square is equal to U square minus 2AS. Here final velocity is 0. U is given to you, that is 40 square minus 2 into 1000 into S. So here it is 1600 divided by 2 into 1000 will give the S. So it is, if you go through the cancellation, this 2, it is 16 upon 20. Okay. So if we calculate it as 8 upon 10, that is 0.8 meter. So final answer which we can have as 0.8 meter. So here what we have done, we have got first electric field. By knowing the electric field, we have got the force. Once we have got the force, we have gone through the Newton's second law of motion. Means this is the application of Newton's second law of motion. Force is equal to mass into acceleration. By this we have got this acceleration, and ultimately by using the equation of motion, we have got the distance traveled by the particle before coming to rest. So we need to know each and everything, because here Newton's second law of motion is applicable. Here we have used the third equation of motion. Here we have got the electric field. Means it is a combination of kinematics as well as electrostatics. Okay. So we have to think over it and do it like this.